Peace be unto you and your family. 11th Chemistry Refresher Course Material, Unit number 4, Chemical Bonding we are going to discuss in this video. What is meant by a chemical bond? A chemical bond may be defined as the force of attraction between the atoms that binds them together as a unit called molecule. A chemical bond may be defined as the force of attraction between the atoms that binds them together as a unit called molecule. So, in a molecule, the atoms are bind together by using a chemical bond. Octet rule or rule of 8. The tendency of an atom to have 8 electrons in the valency cell is known as the octet rule or the rule of 8. The tendency of an atom to get 8 electrons. Oct indicate 8. Example, sodium atomic number 11, it will readily lose 1 electron to attain neon's electronic configuration. Similarly, chlorine has electronic configuration atomic number 17, 287. It readily gains 1 electron from other atom and obtain stable electronic configuration. Sodium atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. And chlorine atomic number 17, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. The outermost cell of chlorine containing 7 electron, the outermost cell of sodium containing 1 electron. Sodium lost 1 electron and chlorine gained that electron. In the sodium atom, first cell there are 2 electron and second cell 8 electron and last third cell containing only an electron. And this is for chlorine, 2, 8 and 7 electrons. After loss of 1 electron, Na plus ion has only 2 cells. That means first cell containing 2 electrons, second cell containing 8 electrons after loss of 1 electron. Come to the chlorine atom. Chlorine, first cell containing 2 electrons, second cell 8 electron, third cell 7 electron, 2, 8, 7. It gain 1 electron. This electron is lost by sodium atom. Gain of electron gives Cl minus ion. After loss and gain of electron, Na plus get octet 8 electron in the outermost cell. Cl minus also get octet 8 electron in the outermost cell. Atoms that have 1, 2, 3 electrons in their valency cell tends to lose electron, whereas atoms having 5, 7, 8 electrons tend to gain electron. Like alkali metal, alkaline earth metal, boron group element or other metal, if they are having 3 electron, 1, 2, 3 electron in the outermost cell, they lost that 1 electron, 2 electron, 3 electron to get octet structure. That halogen, 17th group element, 16th group element, chalcogens and nitrogen group element, pnictogens, these are gain the required number of electron to get 8 electron. Halogen gain 1 electron, chalcogens gain 2 electron, pnictogens gain 3 electron. Lewis dot structure. Lewis dot structure consists of the symbol of the element surrounded by dots representing the electrons of the valency cell of the atom. So, in the case of sodium, the valency cell containing only 1 electron. Therefore, we have to write the symbol of sodium Na. Near sodium symbol, we have to put 1 electron. Chlorine, valence electron 7. So, by putting Cl near, we have to put 7 electron, that is Lewis dot structure. Now, we are going to discuss Lewis dot structure. The unpaired electrons in the valency cell is represented by a single dot, whereas the paired electrons are represented by a pair of dots. Symbols like crosses or circles may be used to differentiate the electrons of the different atom in a molecule. Come to this table, elements, atomic number, valence electron, Lewis dot structure. Hydrogen atomic number 1, it has only one electron, therefore that one electron is put as a dot near the symbol of the element. Hydrogen, one dot, indicate one valence electron. Helium atomic number 2, we know the electronic configuration is 1s2. S orbital has only one orientation. In s orbital, plus half spin one electron, minus half spin another electron. So this pair of electron is indicated as a double dot, pair of electron. Carbon atomic number 6, electronic configuration 1s2, 2s2, 2p2. Valency cell means outermost cell containing 4 electrons. All these 4 electrons are indicated around the carbon atom. Come to nitrogen. Nitrogen atomic number 7, electronic configuration 1s2, 2s2, 2p3, atomic number 7. Outermost cell containing 5 electrons. 5 electrons are indicated as one pair of electron and 3 unpaired electron. Oxygen atomic number 8, electronic configuration 1s2, 2s2, 2p4. Outermost cell containing 6 electrons. All the 6 electrons are paired electron. 1, 2, 3 pair of electron. Now come to the classification of chemical bonding. Chemical bonding is first classified into a strong bond and a weak bond. Under strong bond, we have ionic bond, covalent bond, coordinate bond and metallic bond. Weak bond, hydrogen bond and van der Waals interaction. These bonds are present in between atom and these two bonds are present in between the molecules. Ionic bond is formed by loss or gain of electron. Covalent bond is formed by sharing of electron. Coordinate bond involved by donation of one pair of electron from one atom to another atom. Metallic bond exists in metals. Come to the ionic or electrovalent bond. So in a chemical bond, when one or more electrons are transferred from one atom to another atom, the electrostatic attraction formed between them is called ionic bond. One atom lose electron, another atom gain electron. Sodium lost one electron becomes Na plus ion and chlorine gain that electron becomes Cl minus ion. It is formed between a metal and non-metal, alkali metal and halogen. Come to the covalent bond. Second type of chemical bond is covalent bond. A covalent bond is that involves mutual sharing of electron between the atoms. Three types of covalent bond. Single covalent bond. One electron is shared between two hydrogen atoms. Double covalent bond. Two electrons are shared between two oxygen atoms. One oxygen shares 2 electrons, another oxygen shares another 2 electrons. Triple covalent bond. Nitrogen shares 3 electrons, another nitrogen shares 3 electrons, thereby a triple bond is formed between two nitrogen atoms. For example, formation of a single bond, chlorine molecule. Chlorine is the outermost cell containing 7 electron, here also 7 electron. Each chlorine mutually share one electron, thereby a chlorine molecule is formed. A single bond is formed between two chlorine atoms. Come to the third type of bond, coordinate covalent bond. It is a type of bond in which one of the combining atom, that means donor atom, donate a pair of electron to another atom, acceptor atom. It is represented by an arrow which points from the donor to the acceptor. Here nitrogen has excess one pair of electron. Boron trifluoride is an electron deficient compound. We can see that around boron atom only 3 bonds. A bond containing 2 electrons, 2, 4, 6 electrons. So boron, instead of getting 8 electrons, it gets only 6 electrons. Therefore, boron is an electron deficient compound. When ammonia is added to boron trifluoride, nitrogen donates a pair of electrons to boron. Therefore, a coordinate covalent bond is formed. This arrow mark indicates coordinate covalent bond. All these bonds are covalent bond. The arrow mark is indicate that a pair of electron is donated from nitrogen to the acceptor atom boron. Next, come to the properties of ionic, covalent and coordinate compound. Ionic compound, physical state, They are crystalline solid at room temperature. But covalent compounds exist in gaseous, liquid and solid form. Coordinate compound exists as gaseous, liquid or solid. So these are solid, gaseous, liquid and solid form, gaseous, liquid or in solid form. Second one is electrical conductivity. Do not conduct electric current in solid state, but in molten state. When dissolved in water, it conducts electricity. It is a bad, covalent compounds are bad conductors of electricity due to the absence of charged particle. Coordinate compounds are also bad conductor of electricity. Come to the melting point. Melting point, high melting point and boiling point, low melting point except diamond and silicon carbide. Higher melting and boiling points than covalent compound but lower than those of ionic compound. Come to the solubility, dissolving nature of ionic compound. Soluble in polar solvent like water, insoluble in non-polar solvent like benzene. So ionic compounds are soluble in inorganic solvent like water and insoluble in organic solvent, non-polar solvent like benzene. Soluble in non-polar solvent, insoluble in polar solvent. Organic compound, soluble in organic solvent, insoluble in water. Insoluble in polar solvent, water, but are soluble in non-polar solvent like benzene. Hardness, high density, hard and high brittle. Neither hard nor brittle, but they are soft and waxy. Coordinate compounds are soft and waxy. Come to the ionic bond. Undergo ionic reactions which are rapid and instantaneous. These undergo molecular reaction in solutions which are very slow. Undergo molecular reaction which are very, very slow. Fajjan's rule. Under chemical bonding, this heading is a very most important heading. Fajjan's rule. Some of the ionic compounds show covalent character. See here, ionic compounds show covalent character. So Fajjan's formulated a set of rules to predict whether a chemical bond is ionic or covalent. When the size of cation is small and that of anion is large, the bond is of more covalent character. Anion size is large means the compound has more covalent character. When the size of cation is large and that of anion is small, the bond is of more ionic character. This is Fajjan's rule. Now come to oxidation and reduction. What is oxidation? Addition of oxygen. Reduction, removal of oxygen. Removal of hydrogen is called oxidation. Addition of hydrogen is called reduction. Oxidation, loss of electron. Reduction, gain of electron. What is the oxidation number? Oxidation number of an element is defined as a formal charge which an atom of that element appears to have when the electrons are counted. Rule number 1. The sum of the oxidation number of all the atoms for a neutral compound is equal to 0. Second rule. The sum of the oxidation number of an ion is the same as the charge on that ion. Rule number 3. Oxidation number ON indicate oxidation number of neutral molecule is 0. Now for an example, 1. Oxidation number of potassium and Br in KBr molecule is +1 and -1 respectively. Oxidation number of hydrogen is +1 except hydride in which it is -1. Oxidation number of oxygen in most cases is -2. Now we are going to calculate the oxidation number of sulfur in sulfuric acid. Sulfuric acid is a molecule which is a neutral molecule. First, separate the atoms present in sulfuric acid. It consists of 2 hydrogen atoms and 1 sulfur atom. How many oxygen atom? 4 oxygen atom in a molecule. The sum of the oxidation state is equal to 0. 2 in the hydrogen oxidation state is +1 and we have to find out the oxidation number of sulfur. Therefore, put it as X plus 4 in the oxygen oxidation state is -2, that is equal to 0. Now X in the 2 plus X in the 4 into 2 are 8 minus 8 equal to 0. Now x minus 6 equal to 0, x equal to plus 6. The oxidation number of sulfur in sulfuric acid is plus 6. When you write the oxidation rate, we have to write the number along with the sign. Plus minus indicate that either loss of electron or gain of electron, therefore the charge is must in the case of indicating oxidation number. So this is about chemical bonding. In this video we completed unit 4 chemical bonding, a very most important units. Thank you for watching. If you like, please subscribe. Thank you very much.